So the kind of factoring we're going to do now is the kind that starts with a trinomial. In this trinomial, as the title suggests, is going to look something like this. You have something x squared. Actually, we're going to do ones that just have a 1x squared plus something times x. We'll call that bx plus c. And it's going to factor into two binomials. Something that's going to look like an x and an x here like that. So I guess what's important is to see that once we have this trinomial goes down to two binomials, we're left with something that's being multiplied, two things rather than one thing. So that's the big thing with factoring trinomials. We're going to do lots and lots and lots of factoring trinomials. Another thing to keep in mind is that you have to check for GCF first. Just like we said, the very first thing we did in this chapter was greatest common factor. So we're going to put this into a list of steps. Step 1, greatest common factor, question mark. If there is one, take it out. Step 2 is to put the polynomial into descending order. That means descending order in terms of the degrees of each monomial. You can see we have a square here, we have a power of 1, and then we have a power of 0. So that's what makes this top one descending order. I should have had the square back. Okay, we're going to start with some examples and kind of launch into this. I know you hate this Cornell Notes style, but let's just do it. So we'll call this example A. I'm going to do x squared minus 18x plus 45. I'm going to put parentheses around the trinomial. And now my plan is to separate this into two binomials. Okay. Now you're going to ask yourself a couple questions. You're going to say, what has to go here in the first slot? I know that it could be x squared and 1, but that would be a problem because then when I FOIL it, I wouldn't get an x in the middle. This is probably going to be x and x. Now, the 45. We're going to look at 45 and try to decide what are the things that add to 45, or sorry, not add to 45, multiply to 45, but add to 18. So they're going to multiply to 45, but add to 18. 45 is 9 times 5. 9 times 5 is 45, but 9 plus 5 is not 18, that's 14. So if I sort of looked at the other things, let's pull a factor of 3 from the 9 to the 5. 45 is also 3 times 15. Now, here's a trick in terms of the factors of 45. If I put a 1 here and a 45 here and start building up, 1, 2 doesn't work, but 3 does. 3, and then I put a 15 over here. 4 doesn't work. 5, 5 times 9. Then 6, no, 7, no, 8, no, 9, no. And we reach 9. So if I kind of put these together now, these are all the possible factors of 45, and they're paired like this. So we're just going to look to see which ones of those would add up to 18. And in fact, the 3 and the 15 do add up to 18. So we have 3 here and 15 here. Now, the signs. They could either be both positive or both negative because we're trying to make them multiply to positive 45. But they have to add to negative 18, so that tells us that they're going to be minus, minus. Finally, we're going to check by FOILing because this should be our answer. But if we check, I get x squared minus 15x minus 13x and then plus 45. And that matches. So this kind of lets us know a few things. First of all, I'm trying to organize here. Let's put this off the right here. If C is positive, if I look back up, C was this last term here. In this case, it was positive 45. If C is positive, our factoring looks like ... It's going to look like x minus m times x minus n, or it's going to look like x plus m, x plus n. They're going to be the same sign because those last two have to multiply to become a positive number. Okay. If c is negative, c being the last number, let's do an example of that. I'm going to draw a line and let's go letter B. We're going to do, let's do x squared plus 2x minus 35. Well, I'm still going to separate it into two binomials with an x and an x. But if c is negative, our factoring looks like this. It's going to be x minus m, but x plus n, or x plus m, x minus n. They're opposite signs. One's going to be a plus, one's going to be a minus. The trick is, now what numbers multiply to 35 but differ by 2? They multiply to 35, but they're going to differ by 2. And that's going to be a 7 and a 5. If you kind of say 7 times 5 is 35, I know those are different by 2. Now we're going to sort of play around with, okay, well, if I put the 7 here and the 5 here, and I FOIL it out, that's going to work. My first is going to be x squared. My outer is going to be negative 5. My inner is going to be a positive 7, x, and my last is going to be negative 35. And that gave me a positive middle term. That matches. Okay, big break. Let's do another one. Let's do w squared minus 18wv plus 45v squared. This is actually very similar to letter A. I'm going to separate it like this. W and W gives me W squared. But if I look at the last one, I'm going to have a V in there too, because I want to make V squared. I just have to figure out, okay, what are the coefficients? What multiplies to 45 but adds to 18? That's the same problem we had before. It's just going to be 15 and 3 with a minus minus. FOIL that out, check, and for the same reason as letter A, we get that original polynomial. So the only thing different about that is that we had V's in the last term and a V in the middle term. But it all works out when we FOIL. D. 2x squared minus 2x minus 60. I'm going to switch colors here, and I want you to notice something about this one. If I look at this one, and I put parentheses around it, I do have a greatest common factor that I could take out before I factor this. If I pull a 2 out, I have x squared minus x and minus 30. Furthermore, I have a negative c value. So now I'm looking to see what do I multiply by to get to 30, but add to get to negative 1, or to get 1 different. Remember, this is a minus 1 there. So I want to multiply to 30, but I want to add to, or subtract to get to a negative 1. Okay, well, 30 is made up of 3 and 10. 30 is made up of 6 and 5. Okay, 6 times 5 works because they're 1 apart. So then I'm going to keep the 2 from before. I've got x, and I know it's going to be 6 and 5, so the question is, where does the negative go? Well, if I want the middle term to be negative, I got to put the negative with a larger number. I'm going to put it with a 6 and keep the positive with a 5. That's my factored form. Okay, I'm a fan of break lines, so let's do another one. And then let's do m squared minus 18x plus 30. This is a positive c. When we have positive c's, we look to see what are we going to multiply to get to 30, but add to get to 18. In this case, negative 18. So that's going to be an m minus and then an m minus. They're going to be the same sign because we want to add them to get to negative 18. We want to multiply them to get to positive 30. So they both have to be the same sign. Otherwise, we wouldn't be able to multiply them to get a positive number for that last term. Well, 3 times 10? No. If I go 3 times 10, that doesn't work at all. I could go 6 and 5, that won't work. Then I could go 15 and 2. 15 and 2 doesn't work. So I just tried, let's try to look at all of my factors. 1, 2, 3, 5, 6, now they were pairing up. 3 and 10, 2 and 15, and 1 and 30. Do any of those multiply to get to 30, but add to get to 18? 6 plus 5 is 11, 3 plus 10 is 13, 2 plus 15 is so close, but it's 17. And no, we don't. So what we have to do is kind of cancel this out here and just say, nope, that is prime. That doesn't work. Let's do another one. I'm going to do 12x minus 20 minus x squared. This one is a little tricky because I want to put it in descending order, so let's rework things. I'm going to go negative x squared plus 12x minus 20. I don't like negatives in front of my polynomials that I'm trying to factor. So what I'm going to do is actually take a negative 1 out. I'm going to take a negative out like this and say x squared minus 12x plus 20. Now I can say I have a positive c value, and I want to multiply to 20, but add to negative 12. So we're going to go two binomials with x and x. 20 is made up of 2 and 10, so this is 2 times 10. Minus minus is going to give us minus 12, because negative 2 and negative 10 add up to negative 12, but multiply to become negative or positive 20. So this is perfectly legit to have that. Negative in front means a negative 1, and then an x minus 2 and an x minus 10. A couple more. We're going to do a squared plus 17ab plus 42b squared. This is another case where our first and our last term have variables in there. That should not be a big deal. When we split it up, I just know this is going to be an a, and this is going to be a b, and this is going to be an a, and this is going to be a b. And they're all positive, which is nice. With positive c values, we just look to see what multiplies to 42 but adds to 17. If you're really, again, confused, we can start doing 1 and 42 and build sort of the factors, all the factors that can multiply. 2 and 21. Nope. I could do 3, and that'd be 3 and 14. Okay, those two add up to 17. So I have 3b and 14 plus and plus. Last one of this set. Let's do 8 minus 9y plus y squared. Now, I'm a fan of descending order, so I'm going to switch this around. Y squared minus 9y plus 8. Again, we have a positive c value, so I'm going to go y and 8, y and 1. Now, I could immediately latch on to the 8 and 1 because I know 8 plus 1 is 9, but 8 times 1 is 8. Minus, minus. And that's a final factored form. So those are examples. Feel free to look at a couple more. We're going to flip over to another video where we're going to look at some different ways to look at this.